without actually solving the equation, list all possible values that would have to be rejected if they appeared as proposed solutions. This is what I would refer to before as a variable restriction. Eventually we'll call them a domain restriction, but for now they are variable restrictions. And what's important to note here is that these are rational, meaning we have fractions. Right? We have fractions here. Okay? These are algebraic because they have variables in them, but they are fractions. What's important is that the denominator cannot be 0. The denominator cannot equal 0. So I want to look at each denominator in each of these two separate equations and make sure they are not 0. So for the first one, I'm going to say, okay, 3x can't be 0. Actually, rather, let's say, what if it is 0? Then what would cause it to be 0? Well, dividing by 3, that would mean that x equals 0. Okay, so this expression is undefined when x is 0. And actually the same thing for the other. 2x equals 0. If we divide by 2, we get x equals 0. So we can say that this is undefined when x equals 0, so x cannot be equal to 0. That's the value. If we found a solution of 0, we would have to say, nope, can't be right, because that would make our expression undefined. Now, for our second equation, we'll do the same thing with our denominators again. We'll say x plus 1 equals 0, or x minus 2 equals 0. What value would make x plus 1 equals 0? Well, that would be x equals minus 1. And what value would make x minus 2 equals 0? Well, adding 2 to both sides, we see that would be x equals 2. So that tells us that x cannot be negative 1 or positive 2, because our expressions would be undefined for that value of x.